Hello, hi everyone. Once again, welcome back to the channel. As a series of Docker OWASP top 10, we already covered till D06. Today, we are going to discuss about D07, that is resource protection. What exactly the resource protection and what happens if the resource was not protected properly, and some example use cases and some real-time commands how we need to use and to protect the resources properly. Let us discuss each and everything in detail. Okay, so here, preventing Docker containers from consuming excessive system resources through a proper limits and monitorings, it is very much essential for maintaining a system stability and security. Basically, it will says we need to make sure how to. We need to make sure to learn how to set up a CPU and memory, disk, and network boundaries. All these uh, resources, and we need to by implementing this we can able to protect your Docker and entire infrastructure as well as host system also. Okay, so that is the like main point of resource protection. Okay, now let us see what exactly the resource protection in a Docker. Okay, so the resource protection involves setting up a explicit boundaries on how much CPU, memory, and disk space, as well as network boundaries or bandwidth, we can say, for each Docker container that can consume on the host system. Okay, so why this particular resource protection came into picture was by defaultly the containers are ephemeral. Okay, so let us see what is going to be happen with a proper limits and what can go wrong with a proper uh, without proper limits. Okay, so without proper like resources protection, that means limit setup, the containers can consume 100% of system resources. So basically this can lead to a host crashes as well as degrading the performance of the host, or else denial of services also will happen, and other containers whatever running on the same host may become a unresponsive, or else that may fail entirely also. Why? Because there is no like resources available to run that particular containers. Okay, that is the about without a limits. And coming to the with the proper limits, each container stays within a defined boundaries that will ensures the like resource uh, fairness will be provided. Okay, why? Because there is a sharing of resources and there will be a good system stability as well, and it supports like multi container orchestration without any noise or neighboring issues. Okay, so that is the point about here, like each container operates with a defined boundaries ensuring a stable multi container environments. And if you wanted to like understand in a simple manner with a non-technical analysis, here is a small example. Okay, think of the resources limits like a speed limits on the highway whenever we are traveling. Basically that will prevent the accidents and that will ensure a smooth traffic flow also for everyone in a safely to reach their destinations or else to do their works. Okay, so that was the a kind of non-technical analysis example. Okay, I think so you got a certain idea what exactly the resource protection, what happens, and what may go well if we set up a resource limits. Okay, now let us see why the Docker containers needs a resource boundaries. Okay, Docker containers share the host OS kernel and resources. That means whatever the host OS having a specific details, that will shares from the host only, right? Whatever the CPU, memory, or disk, or any network bandwidth, whatever the container Docker container is using, that is came from the host only. Okay, and without limits, one misbehaving container can hog everything entire environment. That will lead to a system-wide crashes also. Okay, so that is the like why exactly the Docker needs a resource boundaries. Okay, and let us discuss what are all the some points where what need to be like what what are those resources and how that will like affect or else how that will impact. Okay, first one was CPU protection. Basically the CPU quota whatever which is having for the host system, we need to make sure to, if we don't specify a certain limit, then entire CPU also can be utilized for a single Docker container if the resource limits was not set, and if some attacker run a kind of like a huge work on that. Okay, and it will basically prevent one container from consuming a like a lot of CPU resource for and not leaving any like space or any CPU for the other containers. And this basically keeps the host system uh, responsive and avoids your performance bottlenecks. Okay, so that is why CPU protection is required. And coming to the second point, which is memory limits. Memory, like uh, the containers which is hungry that can trigger out of memory. Obviously, if we don't set up a memory limits for one container, okay, so that may also cause the crashing the host, like host system also, and basically memory limits prevents these like accidents. And the third point was disk space controls. It will basically prevents the containers from filling up the host file system completely. Basically, the containers that write excessive logs or some temp files that can fill up the host file system very quickly. And with the proper disk like space allocation, that will help to avoid this kind of risk. Okay. And the fourth point was network bandwidth. It will ensure a fair network access and prevent a bandwidth exhaustion attacks. This particular limit bandwidth to prevent a denial of services also. You may heard a DDoS attack. Okay, a DOS means denial of services. So in such scenarios, and that will ensure fail the access across the containers. So that is why the network bandwidth providing a kind of a limits for that is also very much important. And here is one of the key risks. By defaultly, as I said earlier, the containers uh, there is no like proper resource limits when we run containers by default manner. This means they can consume like 100% of CPU also, as well as memory, disk, bandwidth, like unless when you explicitly specify with the proper boundaries, then only they can act accordingly. Otherwise, by defaultly, the system like Docker will consume all host system. It has that capabilities or power. Okay. And coming to the next slide, where we are going to discuss about some example like a typical container resource limits, how to set up. Okay, here are the some recommended starting resource limits for different types of containerized applications in production environments. Okay, let us see one by one. Okay, it is just a kind of example how the like application and the associated limits for that. Okay, if you see here, the first one was web application. It has provided 0.5 CPU cores and 512 MB RAM. It will be ideal for moderate traffic web services. And the second one was database containers. It have provided a two core CPUs, and these are the kind of recommendations we can say. Okay, and it completely depends upon the what kind of workload it was and what is the purpose of those containers. Okay, and the memory was here 2 GB, and it is suitable for production databases without. I mean, with a caching memory also. Okay, and the third point was background worker, basically worker service or something like that. Okay, so here the 0.25 CPU and 256 MB RAM. So it is designed for queuing process and batch jobs to perform the batch jobs. Okay, and the fourth point was monitoring services. It requires only 0.1 CPU cores and memory was 128 MB, and it is suitable for lightweight agents for metrics and health checkups to perform those. Okay, and here is the just one small point for you. Start with a conservative limit like 25 to 50% of expected uses and scale up based on the monitoring data. Okay, this completely, as I said earlier, it depends upon the what kind of use case and what the actual task which was doing by that container. Okay, and here are the some additional limits to a container. By using these particular arguments, we can set up like disk uses like input output with the help of arguments hyphen device read bps and device write bps. So this was the like what is the usage of a disk we can specify, and the network access also like network bandwidth via the TC in custom networks we can specify this, and the file descriptors also. If we specify this, then it will set up a kind of limit to that count. Okay, and the process count, it will set up the process count process ID till this particular limit. Okay, so these extra controls will help to prevent the resources exhaustion, and that will maintain a system stability across all the container types. Okay, and moving to the next slide where we will be discussing about how to set up a Docker resource limits. Okay, here the resource limits can be configured by using a Docker CLI commands as well as Docker Compose files or else Kubernetes resource specifications also. Um, here are some practical examples for each method. Okay, uh, let us now look on that. Okay, the first method was, let me scroll little down. Yeah, the first method was Docker CLI method. Okay, Docker CLI example we can say. So here is the first one where basic memory and CPU limits was provided. Based upon this simple example, you will get to know these particular commands runs a Nginx image, Nginx container we can say, with a 0.5, that means a half CPU core and 512 MB of memory RAM. Okay, so this was the command docker run --- memory that will limits to this, and CPU that will limits to this and this particular container. And coming to the second one, where advanced resource controls. Now it was like a deeper. This particular command sets a memory here, and then swap space also, as well as the CPUs, and even the number of process inside the container. Okay, like how many processors that need to be there. Okay, and what is the PID limits, and then finally container name. Okay, so it is a kind of advanced resource controls. It is like a basic first one. Okay, and then third one was which is a kind of uh, disk input output limits. uh, Here you can also control the disk, like a read read or write speed. What is the speed of that, by using a kind of these particular device flags. This basically helps to prevent your containers from hogging like disk bandwidth. So this was the command docker run -device read bps, device write bps, and this was the like space and sorry, a kind of location, as well as what is the like speed we can say, or else bandwidth. Okay, 1 MB. Okay, and finally the container name. So that is the example for a Docker CLI. Okay, now let us see another method, which is Docker Compose configuration. So basically, uh, if you are using a Docker Compose, you can define the resource limits directly within this particular YAML configuration. Okay, whatever you are saying here, it is a Docker configuration file .yaml file. Okay, and here is a like this particular sample configuration for a web service Nginx. Okay, so this particular example, what it does was, it was limits. Limits defining the like maximum resources that particular container can use, and the reservations for the minimum guaranteed resources. This particular thing basically helps the orchestrators like Docker Swarm or Kubernetes uh, to schedule the containers more efficient manner. Okay, so this is how and where you need to specify the limits, CPU, memory, and these are the like memory and CPU's reservation. And this was the image name. This is a kind of a typical configuration file, like basic syntax. And this was the like a key thing where we are specifying limits. Okay, and remember the best practice was always you need to uh, test your resource limits in a like staging environment before you are pushing that into your production. Why? Because like every application behaves like differently under load. So monitor that in a staging environment and adjust accordingly, and then push into a like a production environment. Okay, so that is a kind of a small suggestion. Okay, and then moving next, where we will be discussing about some attack vectors for D07. Okay, what can go wrong without limits? So what is the attack vectors and what can go wrong? Like both will be covered here. So it is like what happens when a Docker containers runs without a proper resource limits. This isn't just a performance issue; it's like a security risk. The attackers and even a like any application which contain a bugs can exploit unlimited containers to crash your entire system. Okay, so now let us see one by one. Okay, so one by one in a clear manner. Here is the attack vector, which is CPU bomb attack. So here a CPU bomb is one of the malicious code that spans the infinite like loop of processes will be utilized. In this process, it consumes 100% of the system CPU, and making the system completely unresponsive. For let's say if you run any another like resource or container, then it won't be available. Okay, so the malicious code spans infinite loops or process to consume 100% CPU, making the systems unresponsive. Okay, and the next one was memory exhaustion. So the let's just read it later. I will explain. Rapid memory allocation to trigger OOM killer, potentially crashing a critical system process. Basically, the attackers or some faulty applications which having a vulnerabilities can rapidly allocate a memory limits, memory until the system hits out of memory stage. Okay, so this particularly triggers the OOM, that is out of memory killer, which may terminate a critical processes or even crash the host system also. Okay, that is the one attack vector, memory exhaustion. And the third attack vector was disk space flooding. So writing massive files or logs to fill up a disk space, preventing a system operations. Basically, what it means was the containers can write a massive logs or files, temp files, filing up to the disk. So once the system file is full, the system operations will fail. Okay, uh, there is no like point. I mean, there is no way or scope to fill once it was filled. So there is, let's say, I mean, here there is no new containers can start, and uh, even if the services are running, that may go down. Okay, so that is the like third one. And the fourth one was network bandwidth abuse, generating excessive network traffic to saturate bandwidth and disrupt the services. By generating a excessive traffic, a container can saturate the network. This disrupt the communication between the service and even the uh, and it can also take the uh, APIs down. I mean, not responsive like that, or else some external integrations down. Okay, so that is the point. I mean, attack vector, one of the attack vector. Okay, and here one point here was here one of the like real world example. The one of the famous you may heard like a fork bomb. Okay, so this particular tiny shell command, whatever you are seeing this different like characters, this particular shell command, what exactly it does was uh, it I mean, it has a capability to spans the thousands of processes in a second. Okay, in some seconds. Let's say if your container has no process limits, if attacker runs this particular command, this can crash the host system very instantly within a second. Okay, so we need to make sure. I mean, that is how the real attacks will happen. Okay, so to prevent those in future, we need to make sure to implement the resource limits. And here also some more points regarding the some common attack techniques. Here are the some common ways how the attackers exploit the containers without a limits. Let's say if the container won't have a limits. One was cryptocurrency mining malware consuming huge CPUs, and the second one was log flooding attacks that fill up your disk space. And the third one was memory leaks in compromised applications. And the fourth one was DOS, that is denial of services attacks through a resource starvation. And resource starvation in the sense consuming all the resources. It is not leaving single like CPU or 1 MB of RAM for the other resources. That is the exact meaning of starvation. And the final point was containers escape attempts via resource pressure. Okay, so these are the like common attack techniques, and whatever the points which is covering here, by implementing above, I mean by uh, adhering to the above attack vectors pointers, we can able to prevent the those not going to be happen. Okay, and here it is like some business impact study for let's say if we ignoring the resource protection, what can affect them. Okay, till which extent it will affect them. So let us have a discussion around this. Okay, yeah, basically the consequences of inadequate resource protection extend beyond a technical failures to a significant business as well as a financial impact. Okay, when the containers run like without a service limits, proper resources limits, the consequences can be devastating. That means not just for your infrastructure, but the entire business also. Okay, now let us walk through the like some statistics with a like emphasis. Here, the first one was 99.9% of service downtime risk. Almost every organization is at a risk of downtime if the containers aren't properly limited. Okay, and the second point was average cost per minute of downtime. Uh, this is the like average cost per minute of downtime, that is 5,600 US dollars. Uh, just for 1 minute of downtime, that can cost around 5,000 US dollars. Imagine, let's say, some 1 hour outage or 30 minutes outage, how much like it will cost the effect. Okay, and the third statistic was 73% of the organizations experience resource related outages. Uh, this is not a rare case. Okay, why? Because nearly 3 out of 4 companies have faced this particular outage due to a resource not a misconfiguration. It's like as mismanagement. Okay, so that is why the resource like maintenance properly is very much important. And 4.2 hours average recovery time. So, and also here, like whatever the effects we are seeing, the recovery is not happening instantly. It was taking some time. On an average, it takes around uh, 4.5 hours to like bounce back the services or whatever the things disrupted. Okay, so I mean this statistics clearly states what exactly the impact of the business. And here are the some business consequences. What can go wrong? Okay, first thing was system crash. Okay, uh, a single container can crash the entire host system. That will leads to a emergency restarts and potential data loss also. Okay, and the second point was security breach. The resource pressure can disable a security monitoring and logging systems. So when the resources are maxed out, the security tools like logging and monitoring may fail. Okay, and that may lead to a some uh, like blind attacks also. Okay, and the third point was SLA violations, the breach of service level agreements resulting in financial penalties. That means if the service goes down, you may like obviously breach the SLA service level agreements and face the financial penalties or loss to the like client trust also will happen. And customer loss, like a poor user experience and service reliability leading to a customer uh, obviously there is no trust will be built for further engagements, right? So some negative reviews will come and long term brand damage also will happen. Okay, and here is the one of the point regarding the one of the case study, uh, one of the real world example also. Okay, a major e-commerce site lost around 1.7 million in just 4 hours during a Black Friday. uh, what exactly it was? It was a single container consumed all available memory and brought the entire system down. Obviously it will cost, right? So when the traffic is in peak stage, that in Black Friday, obviously other system cannot handle that traffic, right? Why? Because one particular system is consuming a lot of like resources, all the resources. So that is why exactly the system resource protection is not negligible. We need to take care of that also. Okay, and here we are going to see uh, identifying containers using a XSU resources. Like how exactly we need to identify whether like the containers are using a too many resources before they crash your system. Like prior to monitoring kind of thing, it is a very much essential thing for maintaining a stability and crashing issues early. Okay, like it wasn't. After crashing and checking, like monitoring and logs like that, before itself we are alerting and making that to be happened. Okay, so this particular proactive monitoring helps to identify the resource uses before they cause system failures and use a built-in Docker tools and external monitoring solutions also. Okay, and let us see like what exactly the options or futures it will be there. Here is the like built-in Docker tools. Docker gives has some several built-in commands to monitor container performance in a real time and historically. Here is the one of the command real to check the real-time resource uses for all containers. Docker stats. Okay, for like all containers information it will show this particular. Whatever the containers which is up and running. Okay, and also like what is the live status of the CPU and memory as well as the network bandwidth and disk input output for every running container it will shows. Okay, and the second one was detailed metrics for a specific container. If you wanted to know, we need to use this particular command. This will focus on one container and get a clean tabular output for the resources it was like actually using. Okay, so this was the command Docker stats and the container name hyphen format. It was like just a tabular format, like what is the container name and what is the CPU memory and input output and all this information will get in a tabular format. Okay, and moving to the next one where resource usage history. To get to the resource usage history, this was the command we need to use. Uh, this particular command runs the Linux top like command inside a container to show the process level uses. Okay, Docker exec container name and top and hyphen bn1. Okay, and here is the one command to compare the limits versus actual uses, how much the resources are limited to and how much the actual usage is happening. Okay, uh, this will helps you to see what like limits were set to that particular container, and how close the container is to like hitting those particular limits. Okay, Docker inspect container name pipe grep hyphen a and 10 resources. Okay, so this is the command, and here we also going to see what to watch for. Okay, major things. Obviously, the CPU monitoring, it will look for containers consistently, which is using above 80 percentage of CPU and showing sudden spikes like that. Okay, and the second one was memory tracking, monitor memory growth patterns and identify a containers approaching the limits. And the third one was a disk input output analysis. It will tracks, that means read write permissions and disk space consumptions trends. Okay, and if there is any sudden increase in a like uh, input output, and network monitoring, it will like observe the network traffic patterns and bandwidth utilizations, and if anything like abusing bandwidth is coming, that will be highlighted there. Okay, and the best practice here was set up the alerts when the containers exceed 80 percentage of their resource limits, and don't obviously wait for to complete 100% utilization, then it may affect the other resources. Okay, so that is the thing here, and here are the some advanced monitoring tools for more deeper insights. We can use external tools, and these are the some tools like Prometheus plus Grafana for metrics collection and dashboards, cAdvisor for container specific monitoring, and Docker system events. This was the command Docker events hyphen hyphen filter and container is equal to, you need to specify your container name. And this was the command to check the system logs. Okay, these particular tools will help to build a complete monitoring pipeline and catch the issues before they like become outage or consume a lot of resources. Okay, and moving to the next slide where we will be discussing about some step-by-step process of fixing the resource potential issues. Sorry, resource protection issues. By following this systematic approach, you can implement a comprehensive resource protection for your Docker containers. Okay, now let us go step by step. Yeah, first thing was access current usage. Start by running a Docker stats. Okay, for 24 to 48 hours. This particularly gives you a like baseline of how much CPU, memory, disk, and network each container typically uses. Okay, and the second point was calculate the baseline limits. Uh, Once you have the average usage with the Hubble, like in the first from the first step, okay, then you need to set up your limits at 150 percentage of that average. Okay, so this basically gives a container a room to handle your traffic spikes without letting them run like a wild manner. Okay, and the third point was implement gradually. That means we need to start with the memory limits first, which is very much most critical, and then CPU followed by disk and then network controls. Okay, and one more important thing was don't try to do everything at once. Okay, and the fourth step was test under a load. Use a like stress testing tools to verify your containers which is performing adequately within the defined resource boundaries. And why? Because it I mean the containers behavior, it depends upon the like what kind of work, and it may like behave like kind of differently when it was taking a traffic and it was having a load. Okay, and the fifth point was monitor and alert. You need to set up your dashboards and alerts to notify you when the containers hit a like around 80 percentage of their resource limits. This basically gives you a time to react before things go critical. Okay, and the final point was document standards. We need to create a internal documentation that defines the standard resource limits for different like application types like web server, database, or background workers. This will basically helps you and you and well as well as a team to stay consistent. Okay, and these are the like steps need to be followed to implement a system, I mean resource protection. And Here is the a quick implementation script. Uh, this particular script will apply a limits to a running containers and create a new ones with a proper boundaries. Okay, so here is the shell script which starts with the shebang, and it will apply a resource limits to a existing running containers. Okay, that means docker run we are not using, docker update. Okay, like this particular docker ps-q, which is existing containers. Okay, so this is the command we need to use. And the another command which creates a new container with a defined limits. Docker run -d -hyphen name, and this was a container name, and memory we are giving 1 GB, and then CPU is 1, and PIDs limits which is 100, and the container name. Okay, and this particular Docker update command is a quick win, we can say. Okay, you can apply a limits to a running containers without restarting them, and that is very much super useful in production environments. And that is the same point which is discussed here. Okay, and moving to the, I think, yeah, final step, final slide, where we are going to discuss about a kind of recap, as well as whatever the resource protection best practices we covered already. We are just going to cover once again, and yeah, as a final touch. Okay, so essential best practices for implementing robust Docker resources protection in a production environment. Okay, yeah. First one was always set limits. Never run a production containers without memory and CPU limits. It is very critical security risk. So it's not just like a performance issue, it's a critical security risk also. Okay, so always set up your limits. And the second point was monitor continuously. That means we need to use a Docker stats command, Prometheus, or some third-party tools, or tools similar to that, to track the resource usage and trends, as well as the patterns of the usage of the resources. That will basically helps us to identify or else to catch the issues before they escalate in your production environment. And the third step was test and optimize. Regularly review and adjust the limits based upon the actual usage data and performance requirements. Uh, Regularly review and adjust the limits based upon the real-time data. What worked last month might not be the same enough for the container if you run today. Okay, so that is exactly why the testing and optimizing accordingly is required. And the last step was set up the alerts. Okay, we need to configure the alerts when the container hits 80% of their resource limits. This basically gives you a time to respond before the users are impacted. Okay, and here is the one of the golden rule for security. Uh, Resource limits are not optional. They are fundamental security control that protects your entire infrastructure from both accidental overloads and malicious attacks. Okay, so this small golden rule you need to keep it in mind, and you need to aware of that. Okay, and here are the some essential resource limits checklist, uh, a kind of a quick checklist to guide your deployments. Okay, first one was memory. Always set hyphen memory limits to prevent out of memory crashes. Okay, and the second one was CPU. Use hyphen CPUs to prevent a CPU starvation of other processors. And PDIs, we need to use we need to set up this hyphen PIDs limit to prevent the fork bomb attacks. Okay, uh, that will basically block the fork bomb attacks. And storage, we need to monitor disk usage and implement a cleanup policies regularly. And network, we need to consider the bandwidth limits for network intensive applications, which having a high traffic applications, we can say. Okay, and here is a a final reminder or a final point I can say. D07, that is resource limits. Protecting resources. Uh, Violations are one of the most common causes of production outages. Make sure the resource limits a standard a part of your deployment process. You need to make sure the resource limits need to be a standard part of your deployment process, not as a afterwards. Okay, so that is the key point. And I think so, whatever the things we have discussed, it was worth, and you utilized your time properly. And thank you so much for watching the video till end. Stay tuned for more videos, and we will be covering the remaining uh, Docker OWASP top 10 in the list in the upcoming videos. Okay. And once again, thank you so much.